Hello everyone. Today we have to learn about numerical integration to evaluate definite integral. So suppose this type of integral is there in I is equal to integral from a to b f of x dx. We have to evaluate this integral applying rule number 1 trapezoidal rule, rule number 2 Simpson's 1/3 rule, and rule number 3 Simpson's 3/8 rule. Now here trapezoidal rule, its formula is value of integral I is equal to h upon 2 into bracket capital X plus 2 times capital R, where capital X is nothing but sum of extreme values of y. Extreme values means what? First value of y and last value of y. Their sum, that is nothing but capital X. And capital R is equal to sum of remaining all ordinates. Ordinates means y0, y1, y2, y3, y4, y5, all these are ordinates. Sum of remaining all ordinates excluding extreme ordinates. Okay, this is trapezoidal rule. Now Simpson's 1/3 rule, statement of this rule, that is nothing but formula integral I is equal to h divided by 3 into bracket x plus 2 times into bracket e plus 4 times into bracket o. Similar to previous case, capital X is nothing but sum of the extremes, or you can say sum of the first and last ordinates. And capital E, this gives sum of the even ordinates. Meaning of this is what? Ordinates with suffix even numbers. And 4 times O. O means sum of odd ordinates. Odd ordinates means ordinates having suffixes odd numbers. And then third rule is Simpson's 3/8 rule. By applying this formula, you can find value of integral I using this. 3 times h divided by 8 into bracket capital X plus 2 times capital T plus 3 times capital R, where capital X is sum of the extremes or sum of first ordinate and last ordinate. Capital T, this is nothing but sum of ordinates with suffix multiple of 3. And then R is sum of the remaining all ordinates. These are formulae for finding value of definite integral applying trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. Here you have to remember, in case of Simpson's 1/3 rule, number of intervals must be multiples of 2. Then only you can apply Simpson's 1/3 rule. And in case of Simpson's 3/8 rule, number of intervals must be multiples of 3. Means if there are 6 intervals, then you can apply all 3 rules. Simpson's 1/3 rule, Simpson's 3/8 rule, and trapezoidal rule. Let us solve problems. Example number 1. Evaluate integral from 0 to 1 dx divided by 1 plus x using number A trapezoidal rule, number B Simpson's 1/3 rule, and number C Simpson's 3/8 rule. Also find the exact value. Means you can find exact value of this integral applying ordinary definite integral method. And these three are numerical methods. Here lower limit is 0, upper limit is 1. Try to get 6 intervals. So we must know value of h, which is length of each interval. And length of each interval, that is h, we can find h is equal to upper limit 1 minus lower limit divided by 6, which is equal to 1/6. Now this is x0 and this is xn. Okay, x0 is 0 and last value x6 is 1. Now to find x1, 0 plus 1/6 is 1/6. Now x2 is equal to 1/6 plus 1/6, that is equal to 2/6. x3 is equal to 2/6 plus 1/6, that is 3/6. Then x4 is equal to 3/6 plus 1/6, that is 4/6. x5 is equal to 5/6, and x6 is equal to 6/6, that is equal to 1. Let y is equal to 1/1 plus x, which is integrand of this integral. Now values of x you can put 0, 1 upon 6, 2 upon 6, 3 upon 6, 4 upon 6, 5 upon 6 and 1 in this to get y0, y1, y2, y3, y4, y5 and y6. So y0 is equal to 1 upon 1 plus 0, that is equal to 1. y1 is equal to 1 upon 1 plus 1 upon 6 and which is equal to 6 upon 7. Replacing x by 2 upon 6 here, that gives y2 and y2 will be 6 upon 8. Replacing x by 3 upon 6 in this function, then y3 is equal to, we can write 6 upon 9. Then y4 is equal to 6 upon 10. y5 is equal to 6 upon 11 and y6 is equal to 1 upon 2. These are values of y, means these are values of ordinates. 1 and half, these are extremes, or you can say extreme values of ordinates, 1 and half. Okay, y2, y4 and y6, these are even ordinates, or you can say ordinates with suffix even number. y1, y3 and y5, these are odd ordinates or ordinates with suffix odd number. Okay, and y3 and y6 are ordinates suffix with multiple 3. Now trapezoidal rule states that value of the integral I is given by I is equal to h upon 2 into bracket x plus 2 times r. Now here x is nothing but y0 plus y6. So we can write here I is equal to h upon 2 y0 plus y6 plus 2 times y1 plus y2 plus y3 plus y4 plus y5 bracket close. Okay, now you can put the values of all the ordinates and value of h. So h is 1 upon 6 divided by 2 into bracket y0 plus y6, that is 1 plus half plus 2 times. Now here sum of all these remaining ordinates, 6 upon 7 plus 6 upon 8 plus 6 upon 9 plus 6 upon 10 plus 6 upon 11. You can calculate this by using calc and get the value of right hand side. So I is equal to 0.6949 and which is value of given integral applying trapezoidal rule. Let us apply Simpson's one-third rule. By applying Simpson's one-third rule, value of integral I is equal to h upon 3 into bracket x plus 2 times sum of even ordinates plus 4 times sum of odd ordinates. Even ordinates are y2, y4. Extreme ordinates are y0 and y6. Odd ordinates are y1, y3 and y5. So put here, hence I is equal to h upon 3 into bracket y0 plus y6 plus 2 times ordinates with suffixes even number, means y2 and y4, plus 4 times ordinates with suffix odd number, that means y1, y3 and y5, y1 plus y3 plus y5. Put the values of ordinates and value of h in this formula. I is equal to h is 1 upon 6 divided by 3 into bracket y0 plus y6, 1 plus half plus 2 times y2 plus y4, 6 upon 8 plus 6 upon 10 plus 4 times sum of odd ordinates. y1 is 6 upon 7 plus y3 is 6 upon 9 plus y5 is 6 upon 11 bracket close. Now we can calculate this by using calculator. So I is equal to 0.6932. Now we have to apply Simpson's 3 upon 8 rule. First of all, formula integral I is equal to 3h divided by 8 into bracket capital X plus 2 times capital T plus 3 times capital R. So I is equal to, we can write 3h divided by 8 into bracket y0 plus y6 plus 2 times only y3 plus 3 times y1 plus y2 plus y4 plus y5. Now put the values of h and ordinates. I is equal to 3 into h is 1 upon 6 divided by 8 into bracket y0 is 1 plus y6 is 1 upon 2 plus 2 times y3 is equal to 6 upon 9 plus 3 times remaining all ordinates y1 is 6 upon 7 plus y2 is 6 upon 8 plus y4 is 6 upon 10 plus y5 is 6 upon 11. Use calc and calculate this right hand side. So I is equal to 0.6932. Now let us find exact value, which is nothing but actual value of integral I. So I is equal to integral from 0 to 1 dx divided by 1 plus x. This is equal to logarithm of 1 plus x from 0 to 1. First replace x by upper limit. So this is equal to logarithm of 1 plus 1 minus logarithm of 1 plus 0. So this is equal to logarithm of 1 plus 1 is 2 minus logarithm of 1 plus 0 is 1. But we know logarithm of 1, its value is 0. Hence I is equal to log 2. Natural logarithm of value 2 is equal to 0.6931. So I is equal to 0.6931. This is actual value of I. Let us solve next sum. Example number 2. Compute the values of integral I from 0.2 to 1.4. Integrand is into bracket sin x minus logarithm of x to the base e plus e to the power x bracket close integral with respect to x by using number A trapezoidal rule, number B Simpson's 1/3 rule, and number C Simpson's 3 upon 8 rule. Okay. To solve this, first of all we have to find out value of h, and you know h is equal to upper limit minus lower limit divided by 6, because we want 6 intervals only. So h is equal to upper limit is 1.4 minus lower limit is 0.2 divided by 6, and this is equal to 0.2. Here x0 is 0.2 and last value, that is x6, is equal to 1.4. Prepare table like this. X0 is 0.2 and x6 is equal to 1.4. H is 0.2. 0.2 plus 0.2, that is x1. 0.4. 0.4 plus 0.2, that is x2. 0.6. 0.6 plus 0.2, that is x3. 0.8. 0.8 plus 0.2, that is x4. 1. 1 plus 0.2, that is 1.2. 1.2 plus 0.2, that is 1.4. These are values of x. Now y is equal to integrand of given integral. Integrand is sin x minus logarithm of x to the base e plus e to the power x. So y is equal to sin x minus log x plus e to the power x. We have to find out values of y, putting the values of x from this table in this function on right hand side. So due to trigonometric function sin x, here we have to select radian mode. First go on mode. Once again click this radian mode, which is number 2. So press number 2. Now it is radian mode. You can find values of y, putting x0 is equal to 0.2 on right hand side of this. So for x0 is equal to 0.2, y0 is what? Sin of 0.2 minus logarithm of x to the base e, that is nothing but natural logarithm, ln 0.2 plus e to the power x. How we can obtain e to the power x? Here first of all press this button and then go on natural logarithm, that gives e to the power x and x is 0.2, 0.2. This gives 3.0295. Similar to this, we have to find out value of y at x is equal to 0.4, that is nothing but y1. So sine of 0.4 minus natural logarithm ln of 0.4 plus exponential means e to the power 0.4. This is equal to 2.7975. Similar to this, for x is equal to 0.6, we have to find out y2. Sine of 0.6 minus natural logarithm of 0.6 plus exponential, its power is 0.6, which is equal to 2.897. Taking 5 digits after decimal point, x1 is 2.79753 and x2 is 2.89759. Similar to this, you can obtain remaining all values of y using calculator. Okay, so that values are x3 0.8, y3 is equal to 3.16604, y4 is equal to 3.55975, y5 is equal to 4.06984, y6 is equal to 4.70418. All ordinates we have obtained. Now use the formula for trapezoidal rule, Simpson's 1/3 rule and Simpson's 3/8 rule to calculate value of integral I applying numerical methods. So trapezoidal rule, value of the integral I is given by h upon 2 into bracket x plus 2r. X means extreme values and r means remaining all values. So I is equal to h upon 2 into bracket y0 plus y6 plus 2 times y1 plus y2 plus y3 plus y4 plus y5. Put the values of ordinates and value of h. I is equal to h is 0.2 divided by 2 into bracket y0 is 3.0295 plus y6 is 4.70418 plus 2 times 2.79753 plus 2.89759 plus 3.16604 plus 3.55975 plus 4.06984. Bracket close. Now use calculator and get the value of I. Hence I is equal to 4.071518. Now let us apply Simpson's 1/3 rule. Formula for Simpson's 1/3 rule is value of integral I is equal to h upon 3 into bracket x plus 2 times sum of even ordinates plus 4 times odd ordinates. Hence formula becomes I is equal to h upon 3 into bracket y0 plus y6 plus 2 times ordinates with suffix even number, that is nothing but y2 plus y4 plus 4 times ordinates with suffix odd number, that means y1 plus y3 plus y5. Now put the values of ordinates and value of h. Hence I is equal to h is 0.2 divided by 3 into bracket y0 is 3.0295 plus y6 is 4.70418 plus 2 times y2 is 2.89759 plus y4 is 3.55975 plus 4 times y1 plus y3 plus y5. y1 is 2.79753 plus y3 is 3.16604 plus y5 is 4.06984. Bracket close. Now use calculator and get the value of right hand side. Hence I is equal to 4.05 213. This is value of integral I applying Simpson's 1/3 rule. Let us apply Simpson's 3 upon 8th rule. Formula for Simpson's 3 upon 8th rule is value of integral I is equal to 3h divided by 8 into bracket capital X plus 2 times capital T plus 3 times capital R. So I is equal to, we can write 3h divided by 8 into bracket y0 plus y6 plus 2 times ordinates with suffixes 3, 6, 9, only y3 is there, plus 3 times remaining all ordinates that are nothing but y1 plus y2 plus y4 plus y5, bracket close. And now put the values of ordinates and value of h on right hand side. So this is equal to 3 times h is 0.2 divided by 8 into bracket y0 is 3.0295 and y6 is 4.70418 plus 2 times y3 is 3.16604 plus 3 times y1 is 2.79753 plus y2 is 2.89759 plus y4 is 3.55975 plus y5 is 4.06984, bracket close. And now using calculator we can calculate right hand side of this. Hence finally value of integral I applying Simpson's 3 upon 8th rule is equal to I is equal to 4.05299. Okay, this is final answer. So in this way we can apply numerical integration methods to evaluate definite integral. All these 3 rules we can apply in this way. So let us stop here. Thank you. Thank you all. Thank you for watching this video. Thanks a lot.